Hi gang, thanks for tuning in to this video for 0.3b. We're going to talk about PERT, we're going to talk about money and how they are related to the number E and its growth or decline of certain values. But the first thing I need you to do is to go back into the module and re-download the notes for 0.3. I realized that the section B, 0.3b part of the notes had some typos and some missing slides, so I've re-uploaded a new file. And so if you could get the newest version of this and not use the one that you were working on earlier, you'll be able to follow this a little bit better. So exponential functions are functions that grow or decline according to a certain model. So the model for an exponential function is always y equals k, which is a constant, and then a to the x. Now a has some specific requirements that goes with it. If a is greater than 1, then we call that a growth situation. And you see the graph for that, for a growth graph, have the horizontal asymptote head up through the number 1 and then head towards infinity. If the value of a is between 0 and 1, so we're talking about a decimal value within there, then we say that that is in decay or decline. And that equation heads down and approaches the asymptote also, but it comes down through the number 1 in it with a negative slope. So growth has positive slope, decay or decline has negative slope. We can apply this to populations that grow. Now this population can be organic or inorganic, so it can be living, or it can be something like a virus, or it can be rust, the way rust grows and spreads. All of these things can be modeled with an exponential equation. So you start with something called a principal value, and that's the P. That's the initial or starting value. Okay, so the value that the population starts with. Then you have a growth rate R. R is usually a percentage. Okay, R percent. And so if it is a percent, remember to move the decimal place over 2 decimal places. N is what we call compounding. Okay, compounded n times per year. You're going to look for words that end in ly, things like daily, weekly, monthly, quarterly, semi-annually. Okay, these are in these words that end in ly. Those tells you how many times it's compounded. That means how many times the cycle repeats itself. Okay, and then T is always the time. We always measure time in years. Okay, not months or it's always measured in years. So we're in the middle of a census year, as 2020. Your family hopefully participated in the 2020 census. The first census was conducted in 1880, back in the 19th century after the Civil War, and it showed that the U.S. had a population at that point of 56.47 million people. If we assume an average annual growth rate in the U.S. of 15%, predict what the census population will be this year in 2020. So we're going to use this growth formula from the previous slide. So the initial population we're going with is the 5647. 1 plus, we're assuming a 15% growth rate, so that's a positive 0.15. And the N is annual, or think of annually. Okay, annually would be 1, so we'll put 1 there. And then 1 again for the same N value. Now we need our time. The time is the years that have passed since we first conducted the U.S. Census. So we're looking at the difference between 1880 and 1220, and that's a difference of 140 years. At this point, you use your calculator to evaluate this and round to the nearest. Always look at 4 decimal places so that you can round to the nearest third decimal place. Make sure you use parentheses correctly and powers correctly in your calculator. So if your calculator is like mine, you're going to get 1776 2 E 10, which means times 10 to the 10th, which means I'm moving my decimal place 10 spots to the right. So I don't want you to use scientific notation. I want you to count over. And so we're looking at 1, 7, 7, 6, 2. The other decimals on there were 96407. And so we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then that's going to give me, if I put my commas all in the right spot, okay, so we're counting here 17,762,964,070 people predicted for the 2020 census. So we'll just have to wait and see how close we were to predicting the population of the US this year. It also applies to buying a car. Now, I don't want any of you to get hosed when you go out to buy your first car. I don't know if you'll be able to afford a new car right away, so maybe you're going to be shopping for a good used car, maybe one that's about 5 years old. So the value of this new car depreciates, okay, so that's telling you it's declining 8% each year, okay, each year means annually, so there's your LY word. Given a purchase price of $32,000, what should you pay? Okay, what would be a reasonable price for a 5-year-old car? All right, A equals the initial principal value, $32,000, 1 plus a negative 0.08, because this is a depreciating value annually, 1, and then 1 again, and then times the year 5. So we could simplify this to say 32,000 times 0.98 to the 5th. Okay, that's simplifying the inside of the parentheses and then having the exponent be to the 5th. I apologize, that should be 9.2. I need to subtract correctly. There we go. And so that gives us a purchase price of $21,090.60. Okay, and then don't just stop there because it's money. It is 608, and so then that means that we'll be looking at 61 cents. So that would be a reasonable price for a car. So maybe if you were going to try and haggle, you would offer $20,000 or $21,000 for that car in 5-year-old condition. We can also use this same formula when we invest our money. Okay, when we go to accounts and we want to put money in and save it. We're not just spending our money, but we want to invest it. We can use this exact same equation. It's called the compound interest formula. And so let's look at some situations where a person is going to invest $2,500 into an account, but they have different compounding rates. All right, we're looking to do one for quarterly, one for monthly, and one for continuously. So using the same amount, same equation, we're looking at $2,500 being the investment. 1 plus 5.4% is 0.054. And now we want to compound quarterly, which means 4 times a year. And so then I also have 4 up here, and then I'm looking for a time span of 10 years. And so that's my equation. I'll use my calculator again to evaluate the value of this. If you want to simplify and clean this up a little bit, you could say that this is the same as 1.0135. Now you don't have to do that, and then this is 40. It's just up to you whether you want to simplify the inside of the parentheses and the power. It's up to you. And then we'll use our calculator to evaluate this. And so the investment amount, when we do quarterly compounding, is going to leave us with 4274.547, and so then that'll be 55. Now let's see how that compares if we invest monthly. So it's the same setup. Everything about the interest rate is the same. We're just changing the 4 to a 12. And so then that's going to change the inside of your parentheses, and so you'd have 1.0045, and that number is smaller, but the power is bigger. And so how is that going to impact the investment? And so if you compound monthly, you'll have a little more money, 4284.82. So maybe $12 more if you compound monthly. And then how would that impact if you compounded continuously? So continuously means you're using the equation for PERT. And so this is so it's a different equation when you want to compound continuously. So 2500 E, there's no 1 plus, it's just E 0.054 times 10. And again, we'll just use our calculator to evaluate that. So we'll have 4290.02. So a little bit more, $6 more if you compound continuously. So read the fine print when you go to invest. The higher the number of compoundings, you'll have that much, a little bit more, maybe $12 or $6 doesn't seem like a lot. But when you start to invest more money than this, or you have a 403B or a 401k, or you're investing over the course of your working lifetime, so you might work for 40 years. So over that course of the time, that money will definitely start to add up. So look for a higher number of compoundings is in your best interest. So we just saw a sample of where we use the number E. E, just like pi, is a specified number. 2.718 is the value for E that is most commonly used. But E is pre-programmed into your calculator. Again, we've got two forms of E. We've got a growth form, and we also have a decay form when it's negative. So we call this the PERT equation. It's just a way to help you remember the order in which those values go. So you'll use PERT for chemistry problems for organic and inorganic material that are decaying radioactively. So a half-life is something that, if left alone, will automatically decay on its own, and to where you have less than what it started with. And half is how long does it take for half of it to decay. So you're left with exactly half of what you started with. So if you started with 10 and you got down to 5, whether something you could think of like water. If you leave a glass of water out long enough, eventually all of the water will evaporate. Now it takes a long time for that to happen, but assuming nothing else changes and there's nothing being added to it, it will eventually decay. So let's see how that works for a chemistry question. A radioactive substance has a half-life of 20 days and you're starting with 5 grams. How much will be left after 4 days? The most common mistake on these questions is that students don't realize they actually have to use PERT twice. Okay, you're going to use PERT 2 times in a row. The question actually stops right here. And you're going to use PERT for the very first part of the equation. So let's look at how that's going to go. We are starting with 5 grams. That's our principal. E to the R we do not know. The time is 20 days. This is where people get stuck. We actually know the value for A. It is half of what we started with. And that's why this thing is called a half-life. Now the number 2.5 isn't in the problem anywhere, but it's implied because of the word half. And so we're going to put 2.5 right here for our A value. So to solve this, we're going to divide both sides by 5. That gives me 0.5, and it gives me e to the r times 20. Now I need to solve for r. The only way I can do that is to use a natural log on both sides. So I'll use a natural log around the 0.5, and I'll use a natural log around the e to the r times 20. And what that does is it cancels out the natural log of e. Okay, remember ln e is 1. And so we're left with the natural log of 0.5, and then when the natural log of e cancels itself out, we're left with r times 20. And so we want to divide both sides by 20. Sorry, I didn't leave myself enough space. So r is the natural log of 0.5, that whole thing, over the number 20. Now you're going to do PERT again. So it's almost like the problem is 2 parts. So we start over with PERT. And now we still start with 5 grams. E to the r that we now have from just solving it. So r is the natural log of 0.5 divided by 20. But our time is different. Our time is now 4. And we'll be finding the amount that we want to find here. Now we can reduce the 4 with the 20. So that will give me 5e to the natural log of 0.5 over 5. And in this situation, the e and the natural log do not cancel each other out because we've got division going on along with the 0.5. So just go ahead and type this straight into your calculator as is, okay? Do not think that you can, that's fake math to do that right there. You do not want to do that. Okay, you do not want to. Okay, that's fake. So please don't do fake math. Just use your calculator to evaluate what that's going to be. Make sure when you do use your calculator that you put parentheses in the right place right there. Okay, that little 0.5 needs its own parentheses before you do divided by 5. You should get, oops, you should get 4.3527. So if we look at the 7, we're going to round this to 4.353 grams is what will be left after 4 days. So practice typing that into your calculator, making sure that you correctly use the parentheses around the 0.5. All right, that finishes up 0.3b. So this is your job now to work on that, and we'll come back together next time and we'll talk about any questions that you have on this lesson before we will move on to logarithms for 0.5. All right, thanks again. Hope you guys are having a good day.